The EB70 represents Selco's debut in the world of panel sizing centres for small and medium-sized companies. Available models are EB70 3200 by 3200, 3800 by 3800 and 4300 by 4400, combining an innovative and ergonomic design with technological contents typically used in a much higher range of machines, such as personal computer-based control, rounded profile offloading tables, a working scratch-proof table and a rear table entirely made of independent idle wheels, avoiding friction and scratches on the panel surface. Furthermore, thanks to its contained dimensions, maximizing space is easy, as it is possible to store panels and other materials under the rear table. The machine main base, which is made of steel, is connected to a secondary one in aluminium with two lateral supports. This bridge-type structure can counteract the force exerted by the pressure beam and also by the weight of the material. The main base also acts as the sole support for the movement of the saw carriage, which, by means of two self-centering prismatic wheels, moves along a hardened and rectified round guide located close to the blade. For each prismatic wheel, there is a counter wheel, assuring constant contact with the guides. The result is the elimination of all vibrations that might compromise the cutting quality. Two pairs of flat anti-rotation wheels, embracing a calibrated rack used for the saw carriage translation, balance the whole structure. This model, as all the Selco saws, has the guide system on one structure, guaranteeing a perfect straight cut. The use of the rack and pinion drive transmission system has the double purpose of cutting maintenance time to zero and, thanks to the helical teeth, producing a continuous fluid movement of the saw carriage. An AC motor, located in the middle of the pusher itself, drives the pusher, and its driving force is transmitted to the pinions connected with the racks. Tempered steel plates located on the guide beams guarantee sliding. The presence of a round guide on the square side of the beam guarantees that the pusher is always parallel to the cutting line. The steel grippers, with front stops that can be trimmed, are floating and independent, avoiding friction on the machine support area with the lower surface of the stack and always ensuring optimum clamping. Creating cutting patterns is very easy using the onboard optimizer Quick Opti, which is a standard feature. It is, in fact, sufficient to insert the dimensions of the board and list the finished panels needed to create a working list made up of the one or more cutting patterns necessary to create the cutting menu. Thanks to the instructions provided in graphic and text form on the simulation page, the operator simply has to load the panels onto the front tables and press the start cycle button, which is optional on the version with a foot pedal. Saw carriage start and stop positions are automatically controlled by the personal computer, according to the length of the material and to the cutting cycle to be carried out. As the rip cuts are made, the operator can rotate the strips and position them ready for the cross cuts. The slots on the pressure beam allow the execution of extremely narrow trim cuts, thus making maximum use of the material. When the rip cuts are being completed, the pusher expels the last strip cut and the relative trim, allowing the operator to start the cross cuts and removing the trims afterwards, reducing cycle times. The panels are always perfectly squared, thanks to the automatic intervention of a side alignment device. A rubber-coated roller mounted on ball bearings that keeps the material always in contact with the squaring fence. On request, a customized label can be produced in real time, containing information about the piece itself to identify it throughout the manufacturing process. The available data can even be printed as barcodes, making subsequent machining operations fully automatic. In order to leave the least possible waste material, third and fourth phase cuts can also be generated. That is to say, cut pieces can be put back into the machine for further processing. In the case of cross-cutting strips with the same width and processing system, the strips can be positioned on top of each other or side by side. In this way, the cycle is speeded up and simplified. But in any case, the online graphic simulation always assists the operator. Thanks to the exclusive rotating flap system, the panel sizing cycle takes place without these flaps lifting up during intermediate cuts, as the panels themselves lift them as they are pushed out of the machine. In order to optimize the suction system efficiency, pressure beam slots are opened only when necessary. Here was a typical cutting cycle, illustrating the extreme simplicity and productivity of this machine. The cutting speed can be programmed manually from 1 to 50 meters per minute, or immediately adjusted by a practical override located on the control panel, which also has a graphic and numerical display in the top right-hand corner of the control screen. Furthermore, the cutting speed is reduced automatically according to the thickness of the stack and the trim dimensions. These pictures show the various cutting speeds used in cutting a single panel. A stack of 3 panels and a very thin trim, optimizing the cutting quality and extending blade life. The page for manual cuts is basically a smart dialogue window between the operator and the machine, which carries out the functions requested step by step. For this reason, it is a machining process perfectly suited for non-standard production. Using just a very few commands, it is possible to machine absolute cuts, incremental cuts, and grooves as optional. In order to speed up and facilitate blade change operations, these are carried out at the front of the machine, right beside the square fence. Although it is manual operation, the standard blade change device is extremely quick, easy, and safe to use. In fact, to remove the hub of each spindle, simply loosen the lock screw. Note that the scoring saw blade, which is supplied with the standard equipment, is independent from the main saw blade and can be activated or deactivated directly from the control panel. The scoring saw blade adjustment, which is manual in the standard configuration, is carried out using a special key above the blade change door. This solution, apart from reducing the machine's side dimensions, greatly speeds up the setup operation following a blade change. In effect, after fitting a new set of tools, the operator can turn the control panel and perform test cuts directly in the blade change area. until perfect alignment between the main blade and the scoring blade has been achieved. The quick change device for unlocking the spindle pneumatically is a system patented by Selco to change blades quickly and safely. The fixing hub is unlocked simply by pressing a button, without the use of any type of tool. Alignment between the main blade and the scoring blade and its vertical adjustment can be carried out electrically from the control panel in 3 different ways. By defining a target position, using a jog step, or calling up one of the 10 adjustment sets memorized, thus making changeover from one set to another extremely quick and easy. The special PFS, post-forming system, scoring blade function, used to size soft-formed or post-formed panels as well as pre-edged strips, is obtained by the automatic quick jumping of the scoring blade when it is close to the square fence during the cutting cycle. Chipping of the entrance point is avoided thanks to a special logic managed by the control software, commanding the raising of the scoring blade at a point corresponding exactly to the corner of the panel. Repeatability of the entrance point is guaranteed by the rack and pinion drive system, which, combined with the inverter, always ensures the same position. The Window Cuts integrated software allows special operations to be carried out, such as cutouts and openings, with extreme ease. The grooving device allows different width and length grooves to be machined. Its adjustment can be manual or electrical. In the last case, setup times are considerably lower. Machining of veneered panels with overhanging edges takes place using special devices that allow the raw panel to be used as a reference so that it can be quickly trimmed.